Yeah, my name is Chris Collins. I'm Research Systems Manager at the University of Hull. My team and I run Viper, the University of Hull's first institutional high-performance computing cluster. So in this talk, I'm going to introduce Viper. I'll say a little bit about the resources that are available, give some examples of how they're used, and then briefly at the end mention what support is available. Next slide, please. So, as I mentioned, Viper is the University of Hull's first institutional high-performance computing cluster. It went live in 2016, and at the time it was one of the first large HPCs in Europe based on, at the time, Intel's Broadwell CPU and Intel OmniPath interconnect. These were both cutting edge and brand new at the time. At the time, it was ranked sort of 6th of HEIs in the country, HPCs and higher education institutions. It still remains a powerful computing resource for researchers across the university. And we're currently in the process of adding some new resource here over the next coming couple of months that will be available tail end of the summer, hopefully. Next slide, please. As mentioned, Viper is used across the university from traditional fields such as physics and astrophysics, engineering, environmental sciences and bioinformatics, right through to more novel uses in health sciences, psychology, business, and even our School of Arts. Over the past few years, work carried out on Viper has contributed to more than 80 publications from across those fields. But the most common featured journals in our publication lists, which is linked to the bottom there, are things like the monthly notices of the Royal Astronomical Society, Astrophysical Journal, and Astronomy and Astrophysics. Next slide, please. So from that, it's clear that we do support a lot of astrophysics work, and there are examples of the work Viper helps to support from the University of Hull's EA Milne Centre, which will be of particular interest to this group of people, I'm sure. Topics such as galaxy evolution and stellar nucleosynthesis. Professor Brad Gibson is the director of the Milne Centre and a member of several of the work packages here. So if you'd like to learn more about these, then have a chat with Brad or Marco as well, who's on this call. Next slide, please. So looking at a bit closer at one of these examples, this is some HPC work on stellar nucleosynthesis. It's from one of our Milne Centre PhD students who submitted his thesis this week, based around calculations done on Viper on a topic aligned to check it to this piece of work. I'll let Marco, if you've got any questions, I'll let Marco answer them. I'm a computer person rather than an astrophysicist. But it's good to see this sort of work carried out by PhD students. Viper is available to all researchers at the university, and it's great seeing it support PhD students. Next slide, please. So what makes up Viper? I won't go into too much detail here. The slides are available, so I'll let you have a little read through if you're interested. But across Viper, we have about 5,500 cores. These are mainly made up of our 180 or so standard compute nodes. These are featuring Intel's Broadwell CPUs. They're 28 cores per node and 128 gigabytes of RAM. We also have, as I mentioned, some enhanced compute nodes coming online this summer. These are based on the latest Intel Cascade Lake CPUs, which are 56 core compute nodes with 380 gigabytes of RAM, which should provide a significant improvement in performance for certain workflows. We also have high memory nodes. These have got a terabyte of RAM, and we've also got GPU-based systems, which have got 4 GPU cards in for certain workflows, which can benefit from accelerators like GPUs. Next slide, please. So all of this is connected via Intel OmniPath low latency interconnect. It's a high bandwidth, 100 gigabits a second, low latency, 100 nanoseconds sort of switch latency. And this sort of graph here just shows the potential performance impact or benefit that can be seen from using OmniPath or low latency interconnect over Ethernet for tasks which run across multiple compute nodes. Next slide, please. So just to finish off the resource, we also have a couple of visualization nodes for those people who need to use sort of 3D graphics or doing post-processing or preparation that requires graphical interfaces. We also have 0.5 terabyte of high performance scratch storage. A lot of the work that we see on Viper produces a lot of data, so we have our own dedicated high performance storage. And all of this runs on top of Linux. It's CentOS 7. and we have a lot of applications and software that's optimized to run on that system. And that is what Viper looks like as well. Excuse me. Next slide, please. So just a quick slide to say what Viper means to our users. It allows them to carry out research that would simply not be possible without such a resource. It provides researchers the opportunities to explore new and novel approaches thanks to the time saved in the processing. This quote was actually from the same PhD student mentioned earlier from the Milne Centre, and this was from a case study we did about 3 years ago now, actually. So it's great to see come full circle and the PhD being submitted this past week or so. Next slide, please. So I just want to give a few examples of the different sort of type of workflows that we see on Viper and how Viper can benefit different experiments. So firstly, looking at a high throughput example, these are sort of jobs that are relatively conservative resource demands. So in this case, a single core, less than 2 GB of RAM, and data storage wise, less than 100 megabytes in total for the whole task. So this is certainly something that could be run on a normal laptop or desktop's PC, but how this can benefit the researchers is this particular researcher expects to need to run about between 2 and 2.5 million jobs over the course of their PhD. So that's certainly something that couldn't be done on a laptop or a desktop, and that's where a resource such as Viper can come in. Next slide, please. So the next example is of start more traditional HPC, which is the parallel usage. So this is when you run a model or a simulation over multiple compute nodes. So in this case, we've got a relatively sort of maybe a medium-sized parallel task. So a model that runs over between 5 nodes, 140 cores on our system, and 20 nodes, 560 cores, utilizing most of the memory on those systems and producing a sort of a medium amount of memory, about 3 to 4 gigabytes per run. So this is something that could be run on a desktop or laptop. It would have to be scaled down a little bit. But what we did see when running this sort of thing was simulation time on a powerful workstation was about 120 hours for a particular test run. And we got that down to about 1 hour on Viper by utilizing the multiple resources of 20 nodes. So it can benefit the researcher significantly in that front. Next slide, please. The final example is a bit more aligned to the work you're talking about today. This is from one of our astrophysics colleagues running Flash, a mesh refinement hydrodynamics code. These large-scale tasks run across between 1,500 cores and nearly 3,000 cores. We have a couple of users running these. The tasks consume between 4 terabytes and 12 terabytes of RAM when running. So it's certainly something that could not be possible without such a resource. Data-wise, they're generating multiple terabytes of output data per task, per run, and they can run for 5 days each individual task. So this is something that simply would not be possible without a HPC resource like Viper, and that's where we see a lot of the impact of the resource that we have. Excuse me, next slide, please. So I just want to finish off by saying the support that will be available. Any successful applications applicants will come in and use Viper much like our normal university researchers do. So Viper is supported by a dedicated HPC administration team. We include research software engineering support in there. We have a wiki site that provides documentation, training material, example jobs, list of applications, everything that hopefully can support users there. We also run virtual drop-in sessions via MS Teams. So applicants will have a university account. They can come along and they can ask any workflow questions. They can have a chat with members of the team to help get them started. And we have a range of tutorial videos which we've been developing over the last year while everyone's been in lockdown. These cover introductions to Linux, introductions to HPC, and then more dedicated and advanced topics specializing in certain applications. And we're happy to work with any users of Viper to help them get going. And next slide, I think the final slide. So there's more information on Viper there. And if anybody wants to ask any questions, then I'm happy to answer them now or get in touch with me. Thanks very much for your attention.